Age-related hearing loss is one of the most debilitating conditions afflicting the geriatric demographic, affecting more than 50% of individuals 70 and older. The common complaint of those affected is an inability to understand speech, especially in acoustically challenging environments. Solving the underlying causes of this issue is one of the goals of the Reckenzone Lab at UC Davis. The Reckenzone Lab specializes in exploring what constitutes age-related hearing loss. My name is Diana Polhac. My major is biological sciences, and I am an undergraduate researcher at UC Davis. Research on this discipline is important because age-related hearing loss has been correlated with the development of social isolation, depression, Alzheimer's, and dementia. Moreover, since we live in an aging world, with the number of geriatric individuals projected to exceed the young by 2050, this will impose a huge financial burden on the government and healthcare institutions. The world will be pressured to rise to the occasion and offer a solution to alleviate ailments of the huge number of elderly. To study age-related hearing loss, we perform three types of experiments on subjects. The temporal processing experiment examines whether or not the neuron's activity is synchronized with the beginning and end of sound stimuli. The spectral processing experiment examines the sensitivity of neurons to different frequencies and intensities. The spatial processing experiment examines the preference of neurons to certain directions. Monkeys spend most of their time in trees, roosting, meaning they sit on branches on their haunches. In a canopy, visibility may be limited at times. Spectral processing allows macaques to collect valuable information about who or what is emitting a noise based on its frequency and intensity, giving them the ability to identify if a predator is nearby without actually seeing it. Spatial processing allows macaques to determine where the sound stimuli is coming from. Temporal processing determines reaction time of the animal based on how quickly their neurons are able to detect and process sound. In the wild, reaction time can determine survival. Since humans are also mammals and our brains are similar to the macaques from an organizational standpoint, our ancestors and therefore we are subject to the same processing strategies as macaques. My project aims to explore the changes that occur in the auditory cortex due to age. To achieve this, we will record from a young, middle-aged, and geriatric monkey. Monkeys age 3 times faster than humans. A 26-year-old monkey is considered geriatric and is about the equivalent of a 78-year-old human. We have finished recording from a middle-aged subject. From analysis of those recordings, I have learned that each neuron generally responds best to only one type of processing method. We've begun recording from a geriatric individual, and while we're nowhere near done, we're able to see differences in the responsiveness of neurons to the processing methods previously tested on the middle-aged macaque.